This is 16mm sound film. Because it's easily shown on small portable projectors, its invention has greatly increased the use and value of motion pictures. These days, anyone can operate a sound projector. The film is a celluloid strip, perforated along one edge. A gelatin coating on one side contains the images of pictures and recorded sound. On black and white film, these images are formed of silver, and on color film, they're formed by dyes. Celluloid, unfortunately, is not the world's strongest material. Therefore, motion picture film must be handled with care to protect it from damage. You see what I mean? Let's take another example. Care must be taken to protect film in transit. Here's a strong fiber box, but see what's inside. If, before we ship a reel of film, we apply a paper band and fasten it securely, at the other end of the line we'll have film, not spaghetti. There are two types of celluloid used in the manufacture of film. One of them, known as cellulose nitrate, is the kind used for the 35mm print shown in the movie theaters. Nitrate film is comparatively strong, but it has the disadvantage of being highly inflammable. It is almost an explosive. Theaters are required to maintain elaborate precautions against fire and to employ highly skilled operators. This is just one of many reasons why it would not be safe to use nitrate film in a portable projector. All 16mm film is made of acetate cellulose. Acetate film is perfectly safe, but it's not as tough as nitrate. Any friction against the surface of moving film is likely to produce a scratch. It shows on the screen as a dark vertical line, like this, and this, and this. Hey there! Get your fingers off the film. That's better. The manufacturers of 16mm projectors carefully design their machines to keep film wear and strain at a minimum. But in running through a projector, the film necessarily touches and rubs against parts of the machine. Here at the gate, for example, the film is pressed between two pieces of metal, the aperture plate and the pressure plate. But see how these plates are made. A wide path has been hollowed out for the pictures to go through, and another has been made for the soundtrack. The important areas of the film are not touched at all. Other parts of the machine, the guide rollers, sprockets, and the sound drum, turn with the film, and so there is no friction. In spite of the manufacturer's care, scratches sometimes occur in the machine. Careless threading is one cause. Here, for example, the operator is allowing the film to scrape the bottom of the lamp house. See those guide rollers? That's what they're for. Film runs through the gate at the rate of 36 feet a minute. Dust and particles of gelatin are accumulating on the surfaces of the plates. Eventually, the hollowed-out spaces are filled with dirt. And so, we have more of those lovely scratches. Before every reel of film, the wise operator uses a brush to clean out the gate. At regular intervals, he inspects the gate for hard particles of gelatin that the brush could not remove. He scrapes them off with a toothpick. He does not use a knife blade or a pin. A metal tool would spoil the polished surface of the plates. The operator also cleans the sprockets and checks the guide rollers to see that they turn freely. While we're talking about scratches, here's another way to make them. The film is wound too loosely on the reel. We think it ought to be tightened, so we grab the reel firmly and pull the film good and hard. This is called cinching the film, and the scratches we get are called cinch marks. They look like this. It's better to leave the film loose than to tighten it by cinching. The perforations along the edge of the film provide the means by which the sprocket wheels of the projector move the film. Here, the operator has been careful to mesh the film perforations with the sprocket teeth. But a bad splice in the film may cause the perforations to jump out of alignment with the teeth, and so new holes may be punched where they don't belong. It's easy to check for this sort of damage while the machine is running. Gently feel the perforated edge of the film as it passes into the take-up reel. If the film is rough or jagged, stop the machine. Look for the source of trouble. The sprockets carry the film with a smooth, continuous motion. But at the gate is a set of claws which move in and out, up and down, to give the film an intermittent movement. Film is threaded so as to leave small loops above and below the gate. Act as shock absorbers, confining the intermittent movement to only a few inches of film. A few torn holes like these may travel safe sprockets. But at the gate, the claws fail to drive the film. The lower loop tightens, and on the screen we have a picture that looks like this. Without its shock absorber, the film is being strained. A few torn holes have grown to be a whole series of them. It's sometimes possible to reform a loop while the machine is running. However, it's better to stop the machine immediately. There will be less damage, and the operator has a chance to check all of the threading. One of the most useful parts of a projector is the wheel. Lets you turn the machine right back. This used to run through the lever of each film before the film is run. The machine is moving slowly as this. It's a simple matter of short mistakes in threading. When a film breaks in two, it can, of course, be repaired. Splice is really a weld, so the trick in making splices is to have the overlapping surfaces absolutely clean. Roughing them lightly with a razor blade will help. And be sure that the cement you use is fresh. The projector is clean and well adjusted. The film is carefully threaded. With proper care, a 16mm film will give hundreds of good showings.